Welcome back to CTN. I'm your host, Robert Van Sloten. The foundation framework is really the most basic framework that exists. It defines a bunch of very useful low-level data classes, protocols which you haven't talked about, some functions, and type defs that end up making the Objective-C language extremely powerful. We're going to cover some basics, a few of the classes and their characteristics. I strongly recommend that you spend time in the documentation window of Xcode to explore various aspects of this. NSObject is the most simplest class. It's the base class, the top of the inheritance hierarchy for all the classes in iOS. Objective-C does not require a single base class, but in iOS all classes inherit from NSObject. NS stands for Next Step, which was the name of the company that Steve Jobs had after he had left Apple, and then it was purchased by Apple when he returned. NSString, which you've already seen, is a NSObject. In other words, inherits from it. There's an NSArray, which is an array of objects. It's an ordered collection. There's NSDictionary, which accesses objects by a key. So it's a key-object pair. So it's a collection of objects that are accessed by a key. Generally, the key is string. There's a very basic class, NSNumber, which represents a number. And then there are cases where you want a number represented by an object. For example, if you wish to store that in an array takes objects, so you have to convert that integer into an object. Now keep in mind that all the low-level C things are still available to you. You can have C language strings, you can have C language arrays. This gives you the kind of power in the object-oriented world. Now, all four of these classes are what they refer to is immutable. In other words, once they're created, their values cannot be modified. They're static. For strings, arrays, and dictionaries, there are mutable versions, which means that they can grow and contract and their values can be modified programmatically. NSMutable string, NSMutable array, NSMutable dictionary. There is no such thing for number because number is just a static object representing the value. There are more classes. There's a lot more of them in Foundation. For example, there's sets and there's ordered sets and so on, but I'm going to leave that up to you to explore. Now to begin with, we're going to start by just talking about the immutable ones. String constants. A constant string object, simply defined as an @ then quotes, and this is a constant string. It's a constant string with a value, a constant string. This declares a pointer to a type NSString, in other words, an immutable string, and sets it equal to that object. NSNumber, well, same sort of thing, @ and then an expression. 20 plus 3 is 23. So the integer 23, that value gets created as an object and is pointed to by the pointer num. Now I could have just had 23 in there and not had the parentheses. You could also do this with floats. In NSArray, you can create by @ square bracket. In this case, the objects in the array are the constant string Bob and the constant string Sue. Array can be accessed. The object of type NSString can be extracted from the array using the bracket notation, and this would be index 0, which would actually be Bob. NSDictionary, it is a key object pair, and there's two pairs in here. Now you notice the curly brackets are used for the creation of this. First key is Bob. The object is an NS number of 25. These are supposed to represent ages. Second key is Sue, and the object is the number 23. You can get access to the values in the dictionary using square bracket notation, and it accesses the object who's keyed by the constant string Bob. Now, what about mutable? This is standard syntax in Objective-C. What this ends up doing is it ends up creating a object. Now I don't have an equal sign on the left hand side there. You can set it equal to whatever you type NS mutable string. It calls alloc, which ends up allocating an instance in the heap and invoking an init method. Very standard pattern. Now if you look at the documentation for these classes in the documentation window, a whole bunch of initializers. This one ends up giving an indication of how big this is going to be. All right. Now, in other words, I'm doing the same thing, but I'm starting out with a size of 1,000. And this is an efficiency thing. It says, it's going to be in this range. Here's a number. It could be bigger, but let's begin here. Now, here's the thing. There is also a class method that can be invoked on the class directly called string with capacity 1,000. Now the second and third line here are, for all practical purposes, exactly the same thing. And it's just a matter of choice of which one you want to use. I think the last one's simpler in terms of readability. It turns out that in earlier versions of Objective-C, before automatic reference counting, you had to do a lot to worry about memory management. In other words, if you had allocated something, you were responsible for releasing it. It wasn't done automatically for you. If you called a class method and got an object back, it would get released later if you didn't end up retaining it. And if you retained it, you had to release it. There are a lot of rules. Now it really doesn't matter because it's done automatically for you. So either one of these two object initializers are fine. You can create an immutable array, and that's what this example is of Bob and Sue, and you can call a method mutable copy, which will end up returning an immutable version. All right. This can also be done for dictionaries. It can't be done for strings. So this is another way you can start with an immutable one, and you can end up with a mutable one. Okay, I want to close out this episode by talking about something very simple. There's a data type called bool, and it's a way of representing yes and no. Bool is a simple type. You notice there's no pointer indication here. And in this case, the variable is true, and I'm setting it equal to yes. So now I have a variable which represents yes. I could also say it is no. And you see this type used quite extensively in the API for turning things on and off and indicating if something is true or not true. Now, if you have a bool, you can actually store it as an NS number. In actuality, these things really aren't real types. They turn out to be type def, so they're really effectively integers. So NS number, the value of which would be the bool value, yes. You can also do this for characters. The value represented by the uppercase A can be stored as a number. That's it for now. Thanks for watching.